Before we can start using NodeRed to visualize the data coming from an Arduino board or to control certain pins on Arduino, which in turn can control some devices, the appropriate code needs to be written on Arduino and we need to check that everything is in order. So first let us do that. So what you are seeing over here on the right is the circuit diagram which I have used for reading the data from the three sensors I am using on Arduino 1. So the three sensors are namely the HCSR04, which is a ultrasonic sensor, LM35, which is a temperature sensor, and W49E, which is a linear Hall effect sensor. Now, so the way the different pins are connected to Arduino is shown over here. Now, in the case of the HCSR04, you have a VCC pin, trigger, echo, and ground. There are 4 pins. If you zoom into the circuit diagram which I have provided separately, the link for that is provided in the description below. You can see the 4 pins. Now what I have done over here is I have connected the VCC to digital input output pin 8, trigger to 9, echo to 10, and ground to 11. So this is how I have connected the HCSR04 to Arduino Uno. In the case of LM35 temperature sensor, there are 3 pins, a VCC, analog output, and ground. The VCC pin is connected to digital input output pin 12 and the ground is connected to the digital input output pin 13. Okay, and then for the linear Hall effect sensor, what I have done is first I have taken the ground from the Arduino board, which is over here, and I have attached it to this particular line on the breadboard, and I have taken the 5 volts and I have attached it over here. And then for the linear Hall effect sensor, VCC is connected to the 5 volts line, ground is connected to the ground line. Please remember that on a breadboard, for these 2 rows, the voltage along the entire length of the row is the same. So whatever voltage we are having over here, it would be the same at this particular location too. And the output, once again, the output from W49E sensor is analog. So this is connected to the analog pin A2, and remember LM35 is connected to A1. So this is the layout I have used. There are multiple ways to connect the sensors to the board, but I have chosen this particular route. On the layout, it may look a little convoluted, but when I have done this physically, it was much more straightforward. Now, once I have done these connections, I have gone ahead and considered this particular code. Once again, the Arduino IDE code corresponding to this Arduino board is provided in the Google Drive, whose link is provided in the description. Now, so a lot of earlier videos have explained as to how we use this code in Arduino IDE in order to communicate to the Arduino Uno board using the using the USB cable. Now over here, so initially, right, so I am first defining the pins. So the temperature output is connected to analog pin A1. The Hall effect sensor output is connected to analog pin A2. So I define that. And then for temperature, LM35 sensor output reading was fluctuating quite a bit as a function of time. So I have used a moving average scheme in order to get a more stable result. So that is for that reason I have this count over here. And then what I display through the serial port is only the average value over a certain number of readings. And then, so as I have defined, for the ultrasonic sensor, the 4 pins VCC, echo, trigger and ground are defined in this manner. And once again, the VCC and ground for this LM35 sensor are taken as 12 and 13. So now this is the code which I have used. I am sharing this code, and I'll only go through the salient points over here. So wherever VCC is there, the digital output is set to high. Wherever ground is there, the digital output is set to low. And then whenever we are reading a value from an analog pin, as the analog output varies from 0 to 5 volt, the reading which we get from the analog pin goes from 1 to 1024. Okay, so 1 to 1024. So sorry, 0 to 1024. Now in the case of the temperature sensor, okay, so this is the conversion, or this is the function which you need to use in order to get the voltage associated with the temperature in millivolts, and then dividing that particular voltage in millivolts by 10 gives you the temperature in degrees Celsius. Please note that the sensitivity of LM35 temperature sensor is 10 millivolt per degrees Celsius. Now what I do is for every 200 readings I am calculating the average value of the temperature which is outputted by this LM35 sensor, and that is the output which I am displaying on the serial port. Now for the Hall effect sensor, once again we take the reading, and in the case of Hall effect sensor, what we do is again, as I said, as the reading goes from 0 to 1024, in the analog output the voltage goes from 0 to 5 volt. So this over here is the output in millivolt minus 2500 millivolt. So the Gauss, the magnetic flux density is supposed to be 0 when output voltage is 2.5 volt or 2500 millivolt. So in order to get the strength in Gauss, you get this output voltage in millivolt minus 2500 divided by 1.45, which is the sensitivity of the linear Hall effect sensor. It is 1.45 millivolt per Gauss. Now once you have calculated these things, then what I do is basically, and by the way, this average value of the temperature and the reading from the Hall effect sensor, I am declaring it as an integer, or basically I am rounding it off to the nearest integer, and that is what I am printing out through the serial port. Now in the serial port, on each line, so see, there are two kinds of serial print commands. One is a simple serial print and another is serial print ln. So ln, when you add it, it goes to the output goes to the next line. Now what I am doing over here is I have written the code to consider a case where you have multiple outputs which you are communicating to your computer or server through this serial communication. So in this case, I am, even though I have only three outputs, temperature, magnetic flux density and distance from the ultrasonic sensor, I have actually, the distance I am outputting it 3 times, okay, in order to sort of consider a scenario where I have 5 outputs, and I am not outputting any other text, I am just outputting the values of these variables, and I put a comma in between. This will really help me with processing the data at a later stage. Now once you take this code and you prepare a circuit layout which matches with the layout I have shown on the right, if you change things on the circuit, you have to change things in the code accordingly. Okay, so once you do that, then what you need to do is first you need to go to tools, select the appropriate port. So in this case, my COM port, communication port for Arduino is COM4, so I am selecting this, and then my board is Arduino Uno, and then I first verify the code. So verifying is basically to check that there are no syntax errors. If there are technical errors, it won't show. Technical means if you make any mistake in the formula, or you have defined something as a float instead of an integer, those kind of things it won't be able to catch. But if you have done some syntax error, for example, if statement, the format is wrong, or serial print, serial spelling is wrong, that kind of a thing, it will be caught when you're doing the compilation. And then after that you press upload. When you press upload, whatever is this code, it will be returned to the Arduino Uno. So now it is done. Now in order to see whether we are getting the right output, just go to tools and then serial monitor. Now once you go to serial monitor, you can see this reading. I'll stop this scrolling by clicking here. Normally what happens is, as new data is coming in, the text moves to the top, so you feel like there is a moving train of data. I have now unclicked this auto scroll, so data is coming but the screen is not changing. Now over here you can see that the temperature, the first reading rounded off to an integer value, is 20 degrees Celsius. The magnetic flux density is 84 Gauss, and the distance of the ultrasonic sensor to the obstacle, in this case a wall, is 133 centimeters. Okay, so this is the output. Now I'll go to auto scroll so that we are looking at this thing. Now what I'm going to do is I have put a scale with a neodymium magnet sticking to the scale next to the linear Hall effect sensor. So if I move this scale, you can see that the data coming from the linear Hall effect sensor, this thing is fluctuating. You can see that it is high at some point, it goes down, it again comes up, and so on. So and if you want to see what is the time at which this is happening, you can click on this, so that so let me once again move this scale. You can see from the webcam which I have attached to. Okay, so now you can see. So see, this is hours. Right now time is 7:15. This is seconds, and this is milliseconds. Okay, now you can see what is the time period of this oscillation. So let us go from peak to peak. Okay, so this is one peak, and this is the second peak. Okay, so peak to peak, it is taking how much time? It is taking nearly 100 milliseconds, or the scale is vibrating at nearly 10 Hertz frequency. Okay, so we will see that there is a better way to visualize these results once we get to NodeRed. Let us now look at the second Arduino circuit in a bit more of detail. So for the second Arduino, what we are doing is we are using this Arduino to control one digital input output pin, which is pin number 13, where I have written signal. Now this single signal is being used to control two relays. The two relays are connected in a slightly different manner. One of the relays is connected in something known as normally open configuration, meaning the circuit that we are using would be off in a normal condition, and when a 5 volt signal is given, then this becomes on. Whereas the second relay is connected in a normally closed, meaning typically the circuit would be, the connection would be on, and when the signal is given it would be off. Whenever you take a relay, you have two aspects to a relay. On one side you are connecting a high voltage supply, high in the sense, in this case I am talking about 240 volt two phase supply. The way you connect any appliance using a relay is like this. Now as far as the connector is concerned, the live wire, okay, is connected directly to the appliance. In this case I am considering a bulb, but as such you can also consider a pump, a motor, a refrigerator, it could be anything. And the neutral is connected to the common or the common connection on the relay. We do this in both the cases, okay. In both the cases the neutral from the external supply is connected to the COM port. Then depending on which mode you are using, whether it is normally open or normally closed mode, from that particular point you take back this neutral connection to the device. Now the relay basically acts like a digital switch. When it is on, you have a closed loop for the power, and when it is off, the connection gets cut over here and the appliance becomes off. Now the switching is done by an electromagnetic switch on the inside of the relay, and it is because of this electromagnetic switch that you hear cut 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 kind of an sound when we are using these kind of relays. Now on the other side, so on one side I had said that you connect this external power supply, and on the other side you have three pins a 5 volt pin, ground pin and a signal pin. Now the 5 volt and the ground are connected to the 5 volt and the ground from the Arduino. We do this for both the relays, and the signal is connected to this digital input output pin number 13. Now in a typical condition 13 is on, okay. If we do not say anything, 13 is on, and when the signal is given, then whatever is the normally open becomes closed and this light will glow. And when the signal, meaning 5 volt is given over here, whatever is normally closed becomes open. Open connection means the circuit is off and the bulb will be off. And to the digital IO pin, when you give a 0 output, then in that case you have toggling, okay. So when you give a 0 output, you go to this open configuration for this one and closed configuration for this one. This way, by giving the signal, we can make this on off. Alright. Now in this particular case it's not a big deal. It's a very simple circuit that you can build using Arduino, and you can run this circuit. Now here what we are trying to do is basically not run this relays using Arduino, but rather run it from this NodeRed directly. And in order to control these pins, okay, we have to use something known as this standard Formatta code. So for this you go to File, Examples, Formatta, Standard Formatta. Okay, you have this code. I'm not going to do anything. Whatever it is, I'm just directly going to verify it. It should run. It is a standard code. Then select this COM5. Okay, for this port select COM5 and then go over here to upload. Okay, so that's it. So now the program has been uploaded to Arduino. Okay, so now the use of IDE is done, and we can now go to this software called NodeRed, and we can see how we can use this software in order to visualize the sensor output results and to control this to control the switches. Okay, so two kinds of a thing, either to do some action or to collect some sensor data. So let us go ahead and see how we can do that. Now once all of this is done, then I go to the terminal and I start my NodeRed server. I'm going to explain in the subsequent videos as to how to go ahead and install this software called NodeRed and what it does. This video I'm just going to show you what you can do with it. So once I start this server, I have to go to the server address. In this case it is 127.0.0.1:1880. I put this in the browser and press enter, and basically it opens this up. I have created two programs in here. So using NodeRed, you can create a flow based programming language like this. So flow based programming language which looks like this. So in here what I am doing is so this is the flow which is corresponding to the first Arduino. So the serial output is taken and it is split into 5 channels, and each channel is being used to either make a gauge, a graph, text or something. And then I have a second flow. This is for the second Arduino, which I use in order to control the 2 lights. Now once I create this, I have to do something called deployment. I do this, and then I go to the user interface. In order to go to user interface, basically whatever address you had typed earlier, you say /UI, standing for user interface. And if you do this, then basically you get many tabs. So the first tab is for toggling the night lamps, which I had shown in the first video. So if I do this, you may not be able to see the lamps, but you can hear the electromagnetic switch sounds. Okay, and then so the temperature right now it's showing as 32 degrees. This is the magnetic flux density reading. As I had shown you earlier, there is a scale which is having a neodymium magnet on it. As I vibrate this scale, you can see that as the gap between the neodymium magnet and the Hall effect sensor changes, the corresponding reading changes. So each time the reading has increased, I have moved the scale and left it alone. So what you are seeing is free vibrations. And then after this, I am going to go to this ultrasonic sensor. So right now I am placing an iPad in front of it. The iPad is at a distance of 12 centimeters from the thing. So as I bring it closer, you can see that the display is being shown in 3 formats, in form of text, as a gauge and as a graph. So as I move this iPad far from the this ultrasonic sensor, the measurement keeps changing. So in the next videos, I'm going to explain as to how to install NodeRed and how to create programs in NodeRed. Thank you.